Question 1. The number of bees leaving a hive was observed and recorded over 14 days at different times of the day. Which Pearson's correlation coefficient best describes the observations? To help visualize the strength and the direction of the correlation between the number of bees and the time of day, I'm going to draw a line of fit by eye through the points on this scatter plot. I'm going to draw this line of fit in such a way so as to minimize the average distance as best as possible between all the points and the line of fit itself. So roughly half the points should be above the line and half the points should be below the line. And the distance between each of these points and the line itself should be as small as possible. Now, it's not a line of best fit, it's just a line of fit. And it's done by eye, so it's not going to be 100% accurate. But it can be close enough in order to give us a visual reference to the direction and the strength of the correlation. Now, looking at this line of fit, we can see that we have a positive correlation since it has a positive gradient between the number of bees and the time of day. And looking at the distance between the points and the line itself, we can see that the points are reasonably close to the line, which indicates a reasonably strong correlation. So we have a strong positive correlation between the number of bees and the time of day as indicated by this line of fit and the closeness of the points to this line of fit. Looking at the responses, the best response will be option D, 0.8. Question 2. A game involves throwing a die and spinning a spinner. The sum of the two numbers obtained is the score. The table of scores below is partially completed. What is the probability of getting a score of 7 or more? The question is asking for the probability of getting a score of 7 or more. Now, out of the 24 cells in the two-way table, we're only interested in the cells that contain the number 7 or greater. Now, to get the number in the cell, we take the number on the die and add it to the number on the spinner. So in this case, we can get 7 here by getting 6 on the die and adding it to 1 on the spinner to give us 7. Now, there are 4 ways of scoring a total of 7. There are 3 ways of scoring a total of 8. There are 2 ways of scoring a total of 9, and there's only 1 way of scoring a total of 10. So out of the 24 cells, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of those 24 contain the number 7 or more. So the probability of scoring 7 or more is equal to 10, which are our favoured outcomes, over 24, which are the total number of outcomes. And 10 over 24 simplifies to 5 over 12. Therefore, the correct answer is option D. Question 3. What is the domain of f of x equals 1 over the square root of 1 minus x? F of x is a rational function. In other words, it's a fraction with the variable in either the numerator or the denominator. In this case, the variable x is in the denominator. Now, this gives rise to 2 conditions. Condition 1, we can't have division by 0, which means the square root of 1 minus x cannot equal 0. That implies that 1 minus x itself also cannot equal 0. But because the denominator is a square root function, this gives rise to another condition in that we can't have a negative value inside the surd. So 1 minus x must be greater than or equal to 0. Now, if we combine these 2 conditions, the first condition is that 1 minus x cannot equal 0. The second condition is that 1 minus x is greater than or equal to 0. The intersection of those 2 conditions means that 1 minus x must be greater than 0. So solving this inequality, I'm going to do that by adding x to both sides of the inequality, which means I don't need to change the direction of the inequality symbol. So we have 1 is greater than x, which implies that x is less than 1. Therefore, the correct answer is option A. Question 4. The graph of a polynomial is shown. Which row of the table is correct for this polynomial? Let's have a look at the graph of this polynomial function in more detail. Firstly, it has a characteristic S shape, which means that it's most likely to be a cubic function. Secondly, as x approaches negative infinity, y approaches infinity. That means as the x values get smaller, the y values are getting larger. And as x approaches infinity, y approaches negative infinity. That means as the x values get larger, the y values get smaller. Now looking at the equations presented in the 4 options, we can see that the equations are presented in factor form. Now a cubic curve will cross the x-axis at least once, but up to 3 times. Going back to our graph, we can see that the curve crosses or touches the x-axis twice. Now let's have a look at this particular crossing point here. We call this a root or a 0 of the polynomial. It has a characteristic parabola shape, concave down parabola shape. And because it has a parabolic shape, the factor will be in the form x minus c in brackets to the power of 2. We call this a double root because the power of this factor is a 2. Also, the value of c will be greater than 0 because this root is located to the right of the origin. And the factor is in the form x minus c, not x plus c. Looking at this root here, if we zoomed in on this particular point, we can see that the behavior of the graph resembles that of a linear function or a straight line function. This is what we call a single root because the factor that contributes to the shape of the curve around that point is in the form x minus b to the power of 1, where b is a constant. And because this root is located to the left of the origin, the value of b will be negative or less than 0. So for example, if b is equal to negative 2, then the factor x minus b is x minus negative 2 and it will become x plus 2. Now hypothetically, the equation of this polynomial graph could be y equals negative x plus 2 in brackets, so that's our single root here, times x minus 1 in brackets squared, which is our double root here. Therefore, the correct answer is option B. Y equals negative x minus b in brackets times x minus c in brackets to the power of 2, with b less than 0 and c greater than 0. Question 5. The diagram shows the graph of y equals f of x, where f of x is an odd function. The shaded area is 1 square unit. The number a, where a is greater than 1, is chosen so that the integral of f of x dx from x equals 0 to x equals a equals 0. What is the value of the integral of f of x dx from x equals negative a to x equals 1? The question is asking for the value of a definite integral, not the magnitude of the area that's bounded by the curve and the x-axis. So in order to answer this question, we need to consider signed area. Let's go back to the question and look for some clues. Now we know that f of x is an odd function. So if we integrate, let's say, from negative 1 to positive 1, the answer will be 0. Since the area above the x-axis from negative 1 to 0 will equal the value of the area from 0 to 1. That's positive area, that's negative area, equal in magnitude but opposite in sign. So adding those together will give us 0. And that's a characteristic of an odd function. Now the next clue is that the shaded area is 1 square unit. So if this was an area question, this would just equal 1. But because we're considering signed area, the area from 0 to 1, in fact, is -1. So the integral from 0 to 1 of f of x dx is equal to 1 when considering signed area. That means the integral from -1 to 0 will equal +1, since this function is odd. And this area here will cancel with this area here to give us 0. Now the last clue is that the number a, where a is greater than 1, is chosen so that the definite integral from x equals 0 to x equals a, so that's from here to here, is equal to 0. So if the value of this region here, or the area of this region, is -1, the value of the area of this region here must be +1, again, because we're considering signed area. So this area here plus this area here will equal 0. That's -1 plus +1 gives us 0. And I've expressed that here. So let's go back to what the question's actually asking us. It's asking for the value of the definite integral from -a to +1. So if the area in this region here is +1, the area in this region here from -a to -1 must be -1. Again, because the function is odd and there's symmetry or point symmetry around the origin. So the area here is -1, the area here is +1, the area here is -1, the area here is +1. The question is asking for the definite integral that encompasses this area, and this area. Which means -1 plus +1 plus -1 equals -1. Therefore, the correct answer is option A. Question 6. The following table gives the signs of the first and second derivatives of a function y equals f of x for different values of x. Which of the following is a possible sketch of y equals f of x? Let's analyze this table of signs. When x is equal to -2, the value of the first derivative, f dash of x, is positive. That means that the gradient of the tangent to the curve where x equals -2 is positive. And the value of the second derivative, f double dash of x, is negative. And that means that the curve is concave down in the region around where x equals -2. When x is equal to 0, f dash of x is equal to 0, which indicates a stationary point where x equals 0. And the value of the second derivative is also 0. And that may mean that there's a point of inflection at x equals 0. And a point of inflection represents a change of concavity from left to right. In other words, the concavity changes around the point where x equals 0. Continuing on, when x is equal to 2, the value of the first derivative is positive, and the value of the second derivative is also positive, which indicates that the curve is concave up in the region where x equals 2. Now, only one of the options has all these characteristics shown, and that's option C. We can see that the curve is concave down here, the curve is concave up here, so there's a change of concavity somewhere in this region, and that occurs at the origin. There's also a stationary point at the origin as well. Therefore, the correct answer is option C. Question 7. It is given that y equals f of g of x, where f of 1 equals 3, f dash of 1 equals negative 4, g of 5 equals 1, and g dash of 5 equals 2. What is the value of y dash at x equals 5? Y equals f of g of x is a composite function. So in order to differentiate a composite function, the chain rule needs to be applied. And the way it works is we differentiate the outer function, which is f, and multiply that by the derivative of the inner function, which is g. So applying the chain rule, we get y dash is equal to f dash of g of x times g dash of x. Now we're interested in the value of the derivative y dash at the point where x equals 5. So substituting 5 for x here and here, we get y dash is equal to f dash of g of 5 times g dash of 5. Now by definition, g of 5 is equal to 1. So I'm going to substitute 1 for g of 5 here, and g dash of 5 is equal to 2. So I'm going to replace this here with 2. So y dash is equal to f dash of 1 times 2, and f dash of 1 is defined as negative 4. So y dash is equal to negative 4 times 2, which is equal to negative 8. Therefore, the correct answer is option A. Question 8. What is the solution of the equation log base a of x cubed equals b, where a and b are positive constants? What the question is asking for here is to rearrange this equation in such a way as to make x the subject. So my first step is to rewrite this equation from logarithmic form into exponential form. So log base a of x to the power of 3 equals b can be rewritten as a to the power of b is equal to x cubed, or x cubed equals a to the power of b. Now to reverse this operation raising to the power of 3, or the cube operation, we take the cube root of both sides. So the cube root of x to the power of 3 is just x, and the cube root of a to the power of b is just the cube root of a to the power of b. However, we can rewrite this in index form. So the cube root of a to the power of b can be rewritten as a to the power of b in brackets to the power of 1 over 3. And applying the power to a power law, that is multiplying this index here with this index here, b times 1 over 3 is just b over 3. Therefore, x is equal to a to the power of b over 3. Therefore, the answer is option B. Question 9. Let f of x be any function with domain all real numbers. Which of the following is an even function, regardless of the choice of f of x? I'm going to answer this question using two different ways. In the first way, I'm going to use deductive reasoning with a strategic definition for f of x to disprove 3 out of the 4 options, which means by deductive reasoning, the fourth option must be correct. And in the second way, I'm going to use the definition of an even function. Select what I think is the correct answer by inspection out of the 4 options presented, and then test that option using the definition to ensure that that option is in fact correct. So using deductive reasoning, I'm going to let f of x equal 2x plus 1. So a simple linear function, gradient 2, y-intercept 1, and it's defined for all real numbers of x. Now 2x plus 1 is neither even nor odd, and that's indicated with the capital letter N. Let's consider option A, 2 times f of x. So 2 times 2x plus 1 in brackets is equal to 4x plus 2, and that's neither even nor odd, so option A is wrong. Let's consider option B. This is a composition of f with itself. So f of x is equal to 2 times 2x plus 1 in brackets plus 1. Expanding the brackets and collecting like terms, we get 4x plus 3, which is neither even nor odd. So option B is wrong. Let's consider option C. F of negative x in brackets squared is equal to 2 times negative x plus 1 in brackets to the power of 2. Expanding this bracket and collecting like terms, we get 4x squared minus 4x plus 1. Now this is a concave up parabola where the vertex is not on the y-axis. So it's neither even nor odd. So option C is wrong. So by the process of deductive reasoning, that means option D must be correct. The second way to answer this question is by definition of an even function. If g of x is equal to g of negative x, then g of x is even. From the options presented, option D looks most likely to be correct. Now we need to check that option D satisfies the definition of an even function. Let g of x equal f of x times f of negative x. Then g of negative x is found by substituting negative x for x here and here. So substituting negative x for x here, we get f of negative x. And substituting negative x for x here, we get a double negative. We get negative negative x, which is positive x. So g of negative x is equal to f of negative x times f of x, which is equal to f of x times f of negative x, since multiplication is commutative, and that's equal to g of x. Therefore, option D is correct. Question 10. The graph y equals x squared meets the line y equals k, where k is greater than 0, at points P and Q as shown in the diagram. The length of the interval PQ is L. Let A be a positive number. The graph y equals x squared over a squared meets the line y equals k at points S and T. What is the length of ST? Let's go through the question. So we have a graph, a parabola, y equals x squared, meeting the horizontal line y equals k at points P and Q. Now, the length of interval PQ is represented with the capital letter L. Now, let A be a positive number, and the graph of y equals x squared over a squared meets the line y equals k at points S and T. Now, I've sketched the graph of y equals x squared over a squared, and I've sketched it wider than the original parabola. Now, it could be narrower, but it's just easier if it was wider, since a can be any positive number. And if a happens to be equal to, let's say, the number 2, that's x squared over 4, that will result in a parabola that's wider than the original parabola. But it doesn't matter what the value of a is as long as it's a positive number. And the points S and T lie on this parabola, and they represent the points of intersection of this parabola and the horizontal line y equals k. Now the question is asking for the length of ST, so that's this length here between these 2 points. But if we look at the responses, it wants the length in terms of capital L. So our first step is to determine the length of PQ, or capital L. And we're going to do that by finding the x-coordinates of points P and Q. Now it helps to know that the parabola y equals x squared and the parabola y equals x squared over a squared are both even functions. So if we get the x-coordinate of one point, then we've found the x-coordinate of the other point, which is a reflection of the original point in the y-axis. So to find the x-coordinates of points P and Q, I'm going to solve simultaneously the equations y equals x squared and y equals k. So I could substitute k for y here and then solve for x. So solving the equation x squared equals k, taking the square root of both sides, we get x is plus or minus the square root of k, and they represent the x-coordinates of points P and Q. So the distance from the y-axis to either point Q or P is the square root of k. So to find the length of PQ, it'll be the square root of k plus the square root of k, which gives us 2 root k units. The next step is to find the x-coordinates of points S and T. And we're going to find it using a similar method. So I'm going to solve the equation x squared over a squared equals k. So again, that's solving simultaneously the equations y equals k and y equals x squared over a squared using substitution. And that's how we end up with this equation. Multiplying both sides of this equation by a squared, we get x squared is equal to a squared times k. And then taking the square root of both sides of the equation, we get x is equal to plus or minus a root k. So the length of ST is equal to twice the length from the y-axis to the point T. Now the x-coordinate of point T is a root k. So doubling that, we get the length of ST is equal to 2 times a root k, which is equal to a times 2 root k. And 2 root k is the length of interval PQ, which we found up here. So the length of ST is equal to A times L, which equals to AL. Therefore, the correct answer is option C. Question 11. The first 3 terms of an arithmetic sequence are 3, 7, and 11. Find the 15th term. The question is asking us to find the value of a particular term in this arithmetic sequence. So we need to use this formula here. This is the formula to find the nth term in an arithmetic sequence if we know the value of the first term and the common difference. So in this formula, A represents the value of the first term and D represents the value of the common difference, or the difference between any 2 successive terms. So in this particular arithmetic sequence, the first term A is equal to 3, and the common difference can be found by subtracting one term from the term immediately after. So in this case, 7 minus 3 is 4, or 11 minus 7 is also 4. And the value of n is 15, since we want to find the 15th term in this sequence. So substituting those values into this formula, we have T15, or the 15th term, is equal to 3 plus 15 minus 1 in brackets times 4, which evaluates to 59. Therefore, the 15th term of this sequence is 59. Question 12. The table shows the probability distribution of a discrete random variable. Part A. Show that the expected value, E of x, equals 2. E of x represents the mean or the average of the random variable x, and it's also represented by the Greek letter mu. And it's found by multiplying each score by its associated probability and then adding all those products together. And I've written it here in sigma notation. So in other words, it's sigma x times p of x, where sigma means the sum of. So I've shown it in 2 different ways. One way is to create a third row under the table, and it's the px row. And I find these values by multiplying each score by its associated probability. So it's similar to the fx column in a frequency distribution table. So 0 times 0 is 0, 1 times 0.3 is 0.3, 2 times 0.5 is 1.0, and so on. And then we add these values together. So I've shown that in the working out here. And adding these values together we get 2 as required. Part B. Calculate the standard deviation correct to 1 decimal place. There are 2 ways we can work out Part B. In the first way, we can use the stat mode on your calculator to enter the data from the table and then calculate the standard deviation directly. And in this case, we get sigma is equal to 0.894 and so on, which rounds to 0.9, correct to 1 decimal place. Alternatively, we can use the formula, the variance of x is equal to the expected value of the square of the random variable minus the square of the expected value of the random variable. So that's e of x squared minus mu squared. So applying this formula, we get var x is equal to 0 squared times 0, so that's the square of the score multiplied by its associated probability, plus 1 squared times 0.3 plus 2 squared times 0.5 plus 3 squared times 0.1 plus 4 squared times 0.1 minus the expected value of x squared. So that's minus 2 squared. And this 2 here we found in part A. So the variance of x evaluates to 0.8. And to get the standard deviation, we need to take the square root of the variance. So taking the square root of 0.8, we get 0.894 and so on, which rounds to 0.9, correct to 1 decimal place. Question 13. Let P of t be a function such that dp dt equals 3000 times e to the power of 2t. When t equals 0, p is equal to 4000. Find an expression for P of t. The question is asking us to find a function given its gradient function. And in order to do that, we need to integrate this expression here. That will introduce a constant of integration, and then we'll need to use the boundary condition given, which is this condition here, when t equals 0, p equals 4000, to find the value of the constant of integration. After that, we can find the expression for P of t. So firstly, let's integrate dp dt. So P of t is equal to the integral of 3000 e to the power of 2t dt. Now, integrating an exponential function, it remains the same. However, we need to divide by the derivative of the index. So 3000 e to the power of 2t when integrated is 3000 e to the power of 2t divided by 2, which gives us 1500 times e to the power of 2t plus the constant of integration c. Let's apply the boundary condition. It is given that P of 0 is equal to 4000. So substituting 0 for t into this expression here and 4000 for P of t or P of 0 here, we end up with this equation. 4000 is equal to 1500 times e to the power of 2 times 0 plus the constant of integration c. Now 2 times 0 is 0 and e to the power of 0 is 1. So the equation becomes 4000 equals 1500 plus c, hence c is equal to 2500. Therefore, P of t is equal to 1500 times e to the power of 2t plus 2500. Here is an alternative solution that does not explicitly involve integration. Now, if the gradient function given is dp dt equals 3000 times e to the power of 2t, what must the original function or the primitive have looked like so that when we differentiate it, we end up with the gradient function looking like this? Now, since it involves the exponential function, e to the power of 2t, the original function must be in this form. In other words, p of t equals a times e to the power of 2t plus c, where a and c are real numbers. So if pt is equal to a times e to the power of 2t plus c, and we differentiate this function here with respect to t, then dp dt is equal to 2 times a times e to the power of 2t. So I've called this equation number 1 and equation number 2. So notice that we have dp dt equals 3000 times e to the power of 2t, but we also have dp dt is equal to 2 times a times e to the power of 2t. Notice that the two forms are similar. Now moving on. If we equate equations 1 and 2, in other words, let these two equations be equal to each other, we can find the value of a. In other words, 3000 times e to the power of 2t is equal to 2 times a times e to the power of 2t. So if we equate the coefficients, this 3000 must be equal to 2a, which means a must equal 1500. Hence, p of t is equal to 1500 times e to the power of 2t plus c. Now we need to find the value of c. Now it's given that p of 0 is equal to 4000. So if we substitute 4000 for p of t here and 0 for t here, we can solve for c. So 4000 is equal to 1500 times e to the power of 2 times 0 plus c, and e to the power of 2 times 0 is equal to 1. So 4000 is equal to 1500 plus c, hence c is equal to 2500. So putting that all together, we have p of t is equal to 1500 times e to the power of 2t plus 2500. If you have time, you can check this answer by differentiating p of t. Question 14. Find the equation of the tangent to the curve y equals 2x plus 1 in brackets to the power of 3 at the point 0, 1. The first thing we need to do is to differentiate this function with respect to x. Now we have a function of a function, or in other words, a composite function. And because it's a composite function, we need to apply the chain rule to differentiate it. So in short, the chain rule works like this. We differentiate the outer function, which in this case is the cubic function, and then we multiply it by the derivative of the inner function, which is a linear function. So y dash, or the first derivative, is equal to the derivative of the outer function, so the 3 comes out to the front, which is why this 3 is here, and we reduce the index by 1, and then we multiply it by the derivative of 2x plus 1, which is 2. So combining all this together, 3 times 2 is 6, so y dash is equal to 6 times 2x plus 1 in brackets to the power of 2. The next thing we need to work out is the gradient of the tangent at this particular point, where x equals 0, y equals 1. So substituting x equals 0 into the gradient function here, we get y dash is equal to 6. Next, we find the equation of the tangent at the given point using the point gradient formula. That is, y minus y1 is equal to m, or dy dx, outside of x minus x1, where x1, y1 represents the coordinates of the given point. So in this case, x1 is 0, y1 is 1. So substituting those values into the point gradient formula, we get y minus 1 is equal to 6 outside of x minus 0 in brackets. And expanding the brackets, and moving this -1 over to the other side, we get the equation of the tangent as y equals 6x plus 1. Question 15. A table of future value interest factors for an annuity of $1 is shown. Part A. Mickey wants to save $450,000 over the next 10 years. If the interest rate is 6% per annum compounding annually, how much should Mickey contribute each year? Give your answer to the nearest dollar. The first thing we need to find is the correct interest factor from the table. We know that the annuity is earning interest at 6% per annum, compounding annually. So there's no division of this interest rate required. So we can reference this column here. We know that the length of one period is 1 year, and the investment runs over 10 years. So we need to reference this row here. So the intersection of this row and this column is this cell here, 13.181. So the interest factor is 13.181. Now to find the value of the yearly contribution, we take the future value, so this is what Mickey wants at the end of 10 years, and we divide it by the interest factor that we found previously. So we're dividing that by 13.181, and that gives us $34,140.05. Now, the question is asking us to give our answer correct to the nearest dollar. So rounding this value here to the nearest dollar, Mickey should contribute $34,140 each year. Part B. Instead, Mickey decides to contribute $8,535 every 3 months for 10 years to an annuity paying 6% per annum, compounding quarterly. How much will Mickey have at the end of 10 years? The first thing we need to find is the correct interest factor from the table. So that's similar to what we did in Part A. However, the situation has now changed. Instead of the contribution being done annually or yearly, it's now every 3 months or every quarter, and it's compounding quarterly. So we need to find the interest rate per quarter. Now it's still 6% per annum, but to get the interest rate per quarter, we need to divide that interest rate by 4. So 6% divided by 4 gives us 1.5% per quarter. Now the total number of compounding periods is given by 4 compounding periods per year, since there are 4 quarters in 1 year, and we multiply that by 10 years to give us a total of 40 compounding periods. Going back to the table, we reference this column here, 1.5% per quarter, over a period of 40 quarters. And this is our interest factor, 54.268. And I've written that here. So to find the future value, which is the amount that Mickey will have at the end of 10 years, we take Mickey's contribution of $8,535 and we multiply that by the interest factor that we just found, 54.268. And that gives us $463,177.38. Therefore, Mickey will have $463,177.38 at the end of 10 years. Question 16. The diagram shows a shape APQBCD. The shape consists of a rectangle ABCD with an arc PQ on side AB and with side lengths BC equals 3.6 meters and CD equals 8.0 meters. The arc PQ is an arc of a circle with center O and radius 2.1 meters, and angle POQ equals 110 degrees. What is the perimeter of the shape APQBCD? Give your answer correct to 1 decimal place. The question is asking for the perimeter of this composite shape, starting from A along to P, and then along arc length PQ, and then from Q to B, B to C, C to D, and then D back to A. So in effect, we have a rectangle with a piece cut out, that's the dotted line PQ, replaced with arc PQ. So the strategy is to start off with the perimeter of the rectangle, take away the straight side PQ, and then add on arc length PQ. So let's focus on this triangle here, OPQ. Now OQ and OP are identical since they are radii of the same circle. So that's 2.1 meters there and 2.1 meters there. And we have an included angle of 110 degrees. So using the cosine rule, we can find the length of straight side PQ. So PQ squared is equal to 2.1 squared plus 2.1 squared minus 2 times 2.1 times 2.1 times cos of 110 degrees. Make sure your calculator is set to degrees and not radians. And that equals 11.83661766. Taking the square root of this value to get the length PQ, we get 3.440438586 meters. I'll do all the rounding at the very end. Now to find the length of arc PQ, we use the arc length formula. That is theta over 360 times 2 times pi times the radius. So 110 over 360, since there are 360 degrees in a full circle. So this gives us the fraction of the full circle that is represented by arc PQ. Multiply that by 2 times pi times the radius 2.1, and that equals 4.031710572. So to get the perimeter, we find the perimeter of the rectangle first, so that's 2 times 8 plus 2 times 3.6. We subtract length PQ, that's the straight side PQ, and then we add on arc length PQ, and that gives us 23.7912 and so on. And rounding this value to 1 decimal place, we get the perimeter is 23.8 meters, correct to 1 decimal place. Question 17. Find the indefinite integral of x times the square root of x squared plus 1 dx. Analysing the integrand, we notice that we have a product of two functions in x. We have the x outside times the square root of x squared plus 1. The next thing to notice is that the product term x is a multiple of the derivative of what's inside the surd. If we differentiate what's inside the surd, x squared plus 1, with respect to x, we get 2x. But what we have outside the surd is half of that. It's just x. In other words, that's a very strong clue that the chain rule was used in order for an x to appear outside of the square root after differentiation. That also implies that the primitive function is of this form here. The constant a, and that's what we're trying to find, times x squared plus 1 in brackets to the power of 3 over 2. Now if we differentiate this function, the power is reduced by 1, so it becomes 1 over 2 or 1/2. And that's where this square root comes from. So I'm going to go with this. By inspection, the primitive is of the form a outside of x squared plus 1 in brackets to the power of 3 over 2, and we want to find the value of a. So what I'm going to do is I'm going to differentiate this function here. So what I'm going to end up with is a multiple of the integrand. So differentiating a outside of x squared plus 1 in brackets to the power of 3 over 2 using the chain rule, we get 3 over 2 times a outside of x squared plus 1 in brackets to the power of half times 2x. So that's the derivative of the outer function multiplied by the derivative of the inner function. Putting that all together, we get the derivative is 3 times a times x times the square root of x squared plus 1. Notice that it looks like the integrand. However, we just want x. We don't want 3 times a times x. So if we equate 3 times a times x with x, that means the value of a must be 1 over 3, since 3 times a third is equal to 1, and that'll cancel out the 3a term. That means the primitive must be 1 over 3 times x squared plus 1 in brackets to the power of 3 over 2. So the integral of x times the square root of x squared plus 1 dx is equal to 1 over 3 times x squared plus 1 in brackets to the power of 3 over 2 plus the constant of integration c. Question 18. A university uses gas to heat its buildings. Over a period of 10 weekdays during winter, the gas used each day was measured in megawatts, and the average outside temperature each day was recorded in degrees Celsius. Using X as the average daily outside temperature and Y as the total daily gas usage, the equation of the least squares regression line was found. The equation of the regression line predicts that when the temperature is 0 degrees Celsius, the daily gas usage is 236 megawatts. The 10 temperatures measured were 0 degrees, 0 degrees, 0 degrees, 2 degrees, 5 degrees, 7 degrees, 8 degrees, 9 degrees, 9 degrees, and 10 degrees. The total gas usage for the 10 weekdays was 1,840 megawatts. In any bivariate dataset, the least squares regression line passes through the point x bar, y bar, where x bar is the sample mean of the x values and y bar is the sample mean of the y values. Part A. Using the information provided, plot the point x bar, y bar and the y-intercept of the least squares regression line on the grid. The first thing I found was the value of x bar, which represents the average of the 10 temperatures recorded. Now here are the 10 temperatures recorded. Either use the stat mode on your calculator or just add the 10 values together and divide by the number of values, which is 10. So adding these values together, we get 50. Dividing 50 by 10, we get 5. So x bar is equal to 5. Next, find the value of y bar. Now, y bar represents the average of the gas usage over the 10 weekdays. And the clue to work that out is found in this line here. So the total gas usage, in other words, the sum of the scores, is 1,840 over the 10 weekdays. And there were 10 measurements that were taken. We don't know the individual measurements. What we do know, though, is the sum of those measurements. So taking the sum of the scores and dividing it again by the number of scores, which is 10, y bar is equal to 1,840 divided by 10, which gives us 184. The final step is to find the y-intercept. And the clue is given in this sentence here. So the equation of the regression line predicts that when the temperature is 0 degrees Celsius, in other words, that's a value that's on the y-axis, the daily gas usage is 236 megawatts. So we can read this directly as the y-intercept, and I've noted that here. So the y-intercept is 236. Now we can take this information and plot those points on the grid. So I plotted the y-intercept here, just taking note that every square vertically represents 2 megawatts. So there are 5 divisions there from 230 to 240, so 236 is just there. And the point x bar comma y bar is this point here. Part B. What is the equation of the regression line? To work out the equation of the least squares regression line, we need 2 bits of information. We need the gradient of the line. We also need the y-intercept. Now the y-intercept is already given, so we don't need to work that out. We just need to make sure that that's incorporated in our final answer. Now to work out the gradient of the line, there's one of 2 methods. Either we can just draw a triangle, work out the rise, work out the run, and gradient equals rise over run, noting that it's a downhill or a downward sloping line, so the gradient will be negative, or we can use the 2-point gradient formula. In my solution, I'm going to use the 2-point gradient formula. And this is the point x1, y1, this is the point x2, y2. So using the 2-point formula, the gradient m is equal to y2 minus y1 in brackets, so that represents the rise, divided by x2 minus x1, which represents the run. And substituting the respective values for y2, y1, x2, x1, we get gradient m is equal to 184 minus 236 in brackets, divided by 5 minus 0. And that evaluates to negative 10.4. So putting that all together, now that we know the gradient and we know the y-intercept, putting it in the form y equals mx plus c, the equation of the regression line is y equals negative 10.4x plus 236. Part C. In the context of the dataset, identify one problem with using the regression line to predict gas usage when the average outside temperature is 23 degrees Celsius. The question is asking us to identify one problem or issue using the regression line to predict gas usage. In this sample solution, I've given 2 problems or 2 issues that I've identified. There may be others, but I'm going to go through these 2 issues one at a time. Firstly, when x equals 23, using the equation of the regression line that we found in part B, we find that the y value, which represents gas usage, is negative 3.2. And that's a nonsense answer. It's invalid since gas usage cannot be negative. It cannot be less than 0. The other reason is that extrapolation beyond the range of data is unreliable, as it cannot be assumed that the model remains linear outside the range of values given. Question 19, Part A. Sketch the graphs of the functions f of x equals x minus 1 and g of x equals 1 minus x in brackets times 3 plus x in brackets, showing the x-intercepts. We can start off by expanding this expression here. In other words, express g of x in expanded form rather than factorized form. So applying the extended distributive law, we get g of x is equal to 3 plus x minus 3x minus x squared. And putting that all together, collecting like terms, we get negative x squared minus 2x plus 3. Now clearly that's a parabola because the degree or the highest power is 2. There's a negative in front of the x squared, which makes it a concave down parabola. And because g of x is originally expressed in factor form, I have the zeros of g of x, in other words, the x-intercepts already. So we know that the parabola will cross the x-axis at x equals 1 and x equals negative 3. So there are some clues already to start drawing the graph of the parabola. Looking at f of x, that's just a straight line, y-intercept negative 1 and a gradient of 1. So it's already in the form y equals mx plus c. So let's have a look at some other clues. So it'll be nice to locate the vertex of the parabola. Okay, we've already established that it's concave down. We've already established that the zeros are at negative 3 and 1. So here and here. Now the vertex is midway, or at least the x-coordinate of the vertex is midway between the two zeros. So the average of negative 3 and positive 1 is negative 1. And I'm just going to note that there. We just want the y-coordinate of the vertex. So we can take x equals negative 1, substitute it for x here in g of x, and we get y equals 4. So the coordinate of the vertex there is negative 1, comma 4. We also know that this parabola is symmetrical about the axis x equals negative 1. And we can use that to help sketch the graph. Some other points, so x equals negative 4, y equals negative 5. When x equals 2, y equals negative 5 as well. And that's this point here and here, just so that we've got a couple of other points, so just helps us to sketch the graph of the parabola. And here is the sketch of the parabola. G of x equals 1 minus x in brackets times 3 plus x in brackets. I've also sketched f of x here. So that's a line with gradient 1 and y-intercept negative 1. Part B. Hence, or otherwise, solve the inequality x minus 1 less than 1 minus x in brackets times 3 plus x in brackets. The term hence or otherwise means either using the graph that was drawn in part A to solve the inequality, or use any other method of our choosing, such as using algebraic techniques. I'm going to use the graph to solve the inequality. What we want to find are the values of x where the line x minus 1 is completely underneath or below the parabola 1 minus x in brackets times 3 plus x in brackets. The first thing I need to establish though are the values of x where f of x is equal to g of x. Even despite the fact that we have an inequality sign here which is less than, which does not include a condition for equality, I still need to find the points where the line and the parabola intersect, in particular the x-coordinates. So from the graph, we can see that the line intersects with the parabola at x equals negative 4 and at x equals positive 1. Inside these 2 points, the line is underneath the parabola, and outside those 2 points, the line is above the parabola. But we're only interested in the values of x where the line is underneath the parabola. So clearly we can see that the solution is going to be values of x between negative 4 and positive 1, not including the endpoints. And we can state that here. F of x is less than g of x. In other words, the line is less than or below the parabola in the interval x greater than negative 4 and less than 1. Therefore, the solution is x is greater than negative 4 and less than 1. Question 20. Find all the values of theta where theta is greater than or equal to 0 degrees and less than or equal to 360 degrees, such that sine theta minus 60 degrees is equal to negative the square root of 3 over 2. Let's have a look at the trigonometric equation. We have the sine of an angle, which is theta minus 60 degrees, is equal to a negative ratio. Now, because the ratio is negative, that means the angle theta minus 60 degrees must lie in either quadrants 3 or 4. And that's from all stations to central. That is, sine is negative in quadrants 3 or 4. The next step is to isolate theta minus 60 degrees. We need to cancel out the sine operation here by taking the inverse sine of both sides of this equation. So effectively, what we're doing is moving this sine over to the other side and it becomes inverse sine. On your calculator, usually that's shift sine. So theta minus 60 degrees is equal to the inverse sine of negative root 3 over 2. And that gives us two angles. It could either be 240 degrees or 300 degrees. Another way to work this out is to work out the inverse sine of positive root 3 over 2. And in that case, you'll get 60 degrees. Then we need to move that angle from quadrant 1 to its equivalent angle in quadrants 3 or 4. So if it's in quadrant 3, we take 180 degrees, add it to 60 degrees, and we get 240 degrees. And if it's in quadrant 4, we start off with 360 degrees and then take away 60 degrees. And that's how we end up with these two angles, 240 degrees and 300 degrees. Now, adding 60 degrees to both of these angles to make theta the subject, we get theta is equal to 300 degrees or 360 degrees. But there's still one more angle that's missing from the solution. If we go back to the interval, theta is defined between 0 degrees and 360 degrees inclusive of the endpoints. Another thing to note is that the period of this trigonometric function here is 360 degrees. What that means is that these solutions will repeat themselves every 360 degrees. So in other words, if we take 360 degrees here, that's one of the solutions, take away 360 degrees. So in other words, go back 360 degrees, you get 0 degrees. And that's another solution. And I've noted that here. So sine of 360 degrees is equal to sine of 0 degrees. And 0 degrees is included in the interval. Therefore, theta is equal to 0 degrees, 300 degrees, or 360 degrees. Further note, let's say for argument's sake that the question is asked where the domain is not specified. In other words, we're dealing with an unrestricted domain. What would the solution look like then? Now, if the domain is not specified, the solutions for theta greater than or equal to 0 degrees and less than or equal to 360 degrees, in other words, these three values here, will repeat every 360 degrees, since the function sine theta minus 60 degrees is a periodic function for starters, which means it'll repeat itself over and over again forever, and it has a period of 360 degrees. So in this case, the solution follows this pattern. We start off with our original three values for theta in the interval 0 degrees to 360 degrees, but then we add 360 degrees to these three values to give us these three values here. We'll get 360 degrees, which is just a repeat of this value here. We'll get 630 degrees here and 720 degrees here. And the pattern will continue forever in this way. It'll also continue forever in the negative direction as well, but that is not shown here. Question 21. The fourth term of a geometric sequence is 48. The eighth term of the same sequence is 3 over 16. Find the possible values of the common ratio and the corresponding first terms. Start by finding possible values of the common ratio by considering the fourth term and the eighth term of this geometric sequence. Now, in order to find the common ratio, we need to use this formula here. That is, the nth term, or Tn, of a geometric sequence is given by the first term a multiplied by the common ratio r to the power of n minus 1. So in this case, the fourth term is ar to the power of 3, and the eighth term is ar to the power of 7. Now, if we take the eighth term, T8, and we divide it by the fourth term, T4, that's equal to 3 over 16 divided by 48. Now, visualizing this sequence, we know that there are 4 common ratios in between the fourth term and the eighth term. In other words, to go from T4 to T8, we need to multiply by r, that takes us to T5, multiply by r again, takes us to T6, multiply by r again, and so on until we get to T8. So we know that there must be common ratio r to the power of 4 separating T4 and T8. But let's show it using algebra. Now, T8 can be represented by a times r to the power of 7. T4 can be represented by a times r to the power of 3. So ar to the 7 divided by ar to the 3 is equal to 1 over 256. So 3 over 16 divided by 48 will give us this fraction here. Let's consider the left-hand side of this equation. The two a's will cancel, so we're going to be left with r to the power of 7 divided by r to the power of 3 using index laws. That gives us r to the power of 4. Now, there are two ways then to get the common ratio r. Either we can take the fourth root of this fraction, like so, and because the index is even, or another way to think of it is it's the square of the square, we will get two values, a positive and a negative value. Another way to think of it is if we take the square root of r to the power of 4, that gives us r squared, and that's 1 over 16. Notice it's positive 1 over 16 because we have to take another square root to get r. So the square root of r squared is r, and the square root of 1 over 16 this time is plus or minus 1 over 4. So either way, the common ratio, or possible values of the common ratio, is r is equal to plus or minus 1 over 4. Now we need to find the corresponding first terms. So when r is equal to plus or minus 1 over 4, using this formula here again, now that we have a value for r, and we can use either the fourth term or the eighth term, and then solving this equation, given that we have Tn and r and n, of course, we can then solve for a, just by rearranging that equation. So when r is equal to plus or minus 1 over 4, a times plus or minus 1 over 4 in brackets to the power of 3 is equal to 48. Solving this equation for a, we get a is equal to 48 divided by plus or minus 1 over 4 in brackets to the power of 3, and that gives us two values, plus or minus 3072. So possible values for common ratio and corresponding first terms are common ratio equals 1 over 4, first term is equal to 3072, or the common ratio is equal to negative 1 over 4, and its corresponding first term is negative 3072. Alternatively, we can use a diagrammatical approach to solve this problem. And I've used a dash diagram here with 8 places. So there's our first term. If we multiply that by r, we get the second term, so that's ar, ar squared, ar cubed, ar to the power of 4, and so on, until we get to ar to the power of 7. So using this diagram, we can deduce that 48 times r to the power of 4 gives us 3 over 16. And we can get r is equal to plus or minus 1 over 4 this way. Likewise, we can use this to then find the corresponding values for the first term A. Question 22. In the rectangular prism shown, AD equals 7 centimeters, AE equals 8 centimeters, EF equals 6 centimeters. Point M is the midpoint of CD. Find angle AEM to the nearest degree. The question is asking us to find the size of angle AEM, which I've marked with the symbol theta. Now, angle theta is inside triangle AEM, which also happens to be a right angled triangle. So in order to work out the size of angle theta, we need two known sides, and then we can apply trigonometry, either sine, cos, or tan, in order to work out the size of angle theta. Now, in triangle AEM, we know side AE, which is 8, and that's given, but we need the length of side AM. But in order to find that, we need to consider another triangle that's connected to it. And that's triangle ADM. So triangle ADM and triangle AEM have this common side, AM. So we can work out the length of AM using triangle ADM. Now in triangle ADM, it's a right angled triangle and we have two known sides. We know that AD is 7. DM, which is half of DC, and DC is 6 centimeters, and half of 6 is 3. So we have the length of the two short sides, being a right angled triangle. We can apply Pythagoras' theorem to find the length of AM. So writing that all down, in triangle ADM, AD equals 7, DM is equal to 3. So by Pythagoras' theorem, AM is equal to the square root of 7 squared plus 3 squared, which equals the square root of 58. And I've left that in exact form. I'll do all the rounding at the very end. Now that we have the length of AM and we have the length of AE, we have two known sides, we can then progress to find the size of angle theta using trigonometry. So relative to theta, AM is the opposite side, AE is the adjacent side, so we'll apply the tan ratio to find the size of angle theta. So in triangle AEM, angle AEM equals theta, AE is equal to 8, and AM is equal to the square root of 58. So tan theta is equal to AM divided by AE, so that's opposite over adjacent, and that equals the square root of 58 divided by 8. Taking the inverse tan of both sides to make theta the subject, we get theta is equal to inverse tan of the square root of 58 divided by 8, which equals 43.59 and so on degrees, which rounds to 44 degrees. Therefore, angle AEM equals 44 degrees, correct to the nearest degree. Question 23. A random variable is normally distributed with a mean of 0 and a standard deviation of 1. The table gives the probability that this random variable lies below z for some positive values of z. The probability values given in the table are represented by the shaded area in the following diagram. The weights of adult male koalas form a normal distribution with mean mu equals 10.40 kilograms and standard deviation sigma equals 1.15 kilograms. In a group of 400 adult male koalas, how many would be expected to weigh more than 11.93 kilograms? The strategy is to work out the percentage of scores that's represented by the unshaded region in this diagram. Now, the shaded region in the diagram gives us the percentage of scores that lie below Z, and they're given in this table of Z scores. However, the question is asking for the number of male koalas that lie above a certain score, not below. But the first thing we need to do is to work out what the corresponding Z score is for this raw or actual score of 11.93 kilograms. Then we can proceed to find this percentage that's represented by the unshaded region, or the percentage that lies above Z. So using the Z score formula, that is raw score minus mu divided by the standard deviation, we have Z is equal to 11.93 minus 10.4 in brackets divided by 1.15, and that equals 1.33, correct to 2 decimal places. Now, using the table of Z scores, the percentage or proportion of scores that lie below Z equals 1.33, so that's this value here, is 0.9082 or 90.82%. But we want the percentage of scores that lie above Z equal 1.33. And that's found by 100% minus 90.82%, since 100% of scores are contained in the normal distribution. So really what we're doing is finding the complement of 90.82%, and that's 9.18%. So in other words, 9.18% of koalas will have a mass or a weight greater than 11.93 kilograms. So the expected frequency of koalas weighing more than 11.93 kilograms, which corresponds to a Z score of 1.33, is found by taking 400, which is the sample of adult male koalas, and multiplying that by 9.18%, and that equals 36.72. So I'm going to ignore the decimal component of this answer since I'm interested in the number of whole koalas. Therefore, 36 koalas out of 400 are expected to weigh more than 11.93 kilograms. Question 24. A gardener wants to build a rectangular garden of area 50 square meters against an existing wall as shown in the diagram. A concrete path of width 1 meter is to be built around the other 3 sides of the garden. Let x and y be the dimensions, in meters, of the outer rectangle as shown. Part A. Show that y equals 50 over x minus 2 plus 1. Looking at the equation, we have y expressed in terms of x, where y is the subject. Looking at the diagram, what we need to find are the dimensions of the garden area. Now we know that the width of the concrete path is 1 meter. We know the length of the outer rectangle is x meters. If we take away 1 meter here and 1 meter here, so in other words, taking away 2 meters, that gives us the length of the garden area, which is 2 meters less than x, which is written as x minus 2. The width of the garden area can be found in a similar way. If we take the width of the outer rectangle and subtract 1 meter, we get a width of y minus 1 meters. Now the area of the garden bed, which is a rectangle, is found by multiplying the length by the width, or the width by the length. It doesn't matter which order. And that's written here. So the width, which is y minus 1, multiplied by the length, which is x minus 2. So notice it's in brackets. So y minus 1 in brackets times x minus 2 in brackets is equal to the area of 50 square meters. Now note that the brackets are not expanded at this point. In fact, if we were to expand the brackets, we'd make the problem more difficult. What we want is y on one side, on the left-hand side, and we want the variable x on the right-hand side. So it's easier to divide both sides of this equation by x minus 2. So we end up with y minus 1 on the left-hand side is equal to 50 divided by x minus 2 in brackets. We could also write it in fraction form as 50 over x minus 2. I just wrote it using the division symbol because I find it a little bit easier to write it using the lines given in this way. The next step is to add 1 to both sides of the equation. So we end up with y is equal to 50 divided by x minus 2 in brackets plus 1. And expressing it in fraction form, we end up with y equals 50 over x minus 2 plus 1. Part B. Find the value of x such that the area of the concrete path is a minimum. Show that your answer gives a minimum area. The area of the concrete path A is the difference between the area of the large rectangle, which is x times y, and the area of the garden, which is 50 square meters. Hence A is equal to xy minus 50. But we want A expressed in terms of the variable x only, not in terms of x and y. So we need to eliminate the y variable somehow. And the reason for that is we want to find the first derivative later on. That'll be our next step. And having two different variables complicates things. We just want A in terms of x because we want the first derivative with respect to x. So we can eliminate the y variable by using what we know from part A, which is y equals 50 over x minus 2 plus 1. So substituting that for y here, we get A is equal to x times 50 over x minus 2 plus 1 in brackets minus 50. Expanding the brackets, we get A is equal to 50x over x minus 2 plus x minus 50. Notice that we have a fraction where the numerator and the denominator are both functions in x. So we'll need to apply the quotient rule on the fraction to find the first derivative, a dash. Now before we do that, note that the derivative of x is just 1 and the derivative of a constant is 0. So applying the quotient rule on the fraction, we get a dash is equal to 50 times x minus 2 in brackets minus 50x over x minus 2 in brackets squared plus 1. Expanding the brackets in the numerator and collecting like terms, we get a dash is equal to negative 100 over x minus 2 in brackets squared plus 1. The question is asking us to find the value of x such that the area of the concrete path is minimized. And that's a value of x that corresponds to a stationary point. We'll obviously need to show that that stationary point is a minimum, and we'll do that later on. But firstly, let's find a value of x that gives us a stationary point, and we do that by solving the equation a dash is equal to 0. In other words, negative 100 over x minus 2 in brackets squared plus 1 is equal to 0. Moving this plus 1 over to the other side, it becomes negative 1. And then multiplying both sides by negative 1, and then multiplying both sides by x minus 2 in brackets squared. So in other words, rearranging this equation to make x minus 2 in brackets squared the subject, we get x minus 2 in brackets squared is equal to 100. Note that x must be positive because it represents the length of a rectangle. Taking the square root of both sides, notice that I've only taken the positive square root. We have x minus 2 is equal to 10, and then adding 2 to both sides of the equation, we get x is equal to 12, and that corresponds to a stationary point. The last step is to show that when x equals 12, the area of the concrete path is a minimum. And we can do that by finding the second derivative, a double dash, and that equals 200 over x minus 2 in brackets cubed. Substituting x equals 12 for x in the second derivative, so in other words, when x is equal to 12, the value of the second derivative, a double dash, is equal to 1 over 5, which is positive. Hence, x equals 12 is a minimum. Therefore, the area of the concrete path is minimum when x equals 12 meters. Question 25. On the first day of November, Gia deposits $10,000 into a new account which earns 0.4% interest per month, compounded monthly. At the end of each month, after the interest is added to the account, Gia intends to withdraw M dollars from the account. Let AN be the amount in dollars in Gia's account at the end of N months. Part A. Show that A2 equals 10,000 times 1.004 to the power of 2 minus M times 1.004 minus M. Using recurrence relations, let's come up with an expression for A1, which represents the amount in the account at the end of the first month. So starting off with $10,000, increasing that by 0.4%, and we do that by multiplying 10,000 by 1.004, and then at the end of the month, take away a withdrawal of M dollars. So A1 is equal to 10,000 times 1.004 minus M. Let's work out the recurrence relation that represents A2, which is the amount in the account at the end of the second month. So starting off with the amount in the account at the end of the first month, increasing that by 0.4%, and then taking away another M dollar withdrawal. But A1 is this expression here, so I'm going to substitute this here for A1. So A2 is equal to 10,000 times 1.004 minus M in brackets, times that by 1.004, which is this 1.004 here, and then take away M, which is this particular M here. So expanding the brackets, we get 10,000 times 1.004 times 1.004, and that gives us 10,000 times 1.004 squared, minus M times 1.004, which is here, and then take away M. So A2 is equal to 10,000 times 1.004 squared minus M times 1.004 minus M. Part B. Show that AN equals 10,000 minus 250M in brackets times 1.004 to the power of N plus 250M. Continuing on the pattern from part A, let's come up with an expression for A3 to make the pattern a little clearer. So following on from part A here, if this is A2, then A3 will equal 10,000 times 1.004 to the power of 3 minus M times 1.004 squared minus m times 1.004 minus m. So I'm going to factorize out minus m or negative m from this term, and this term. So A3 is equal to 10,000 times 1.004 to the power of 3 minus m outside of 1 plus 1.004 plus 1.004 to the power of 2 in brackets. Now already, just from A3, we can see a pattern forming here. We can see what's in brackets is a geometric progression, or in fact a geometric series, where the first term is 1 and the common ratio is 1.004. So from this point, we can generalize the pattern from A1, A2, and A3. So in other words, we're going to come up with an expression for AN, which is the amount in the account at the end of the nth month. So AN is equal to 10,000 times 1.004 to the power of n minus m outside of 1 plus 1.004 plus 1.004 squared plus plus 1.004 to the power of n minus 1. And we get this n minus 1 by observing the pattern from A3. So if that's 3 here, that corresponds to this 3 here. This value here, or this index here, should be 1 less than this value here, which is why this is n minus 1. So from this point, we just need to clean the expression up. So we have AN is equal to 10,000 times 1.004 to the power of n minus m outside of this expression here, which we now know is a geometric progression or a geometric series. And because we know the first term and the common ratio, we can replace this series here using the formula for the sum of a geometric progression. So rather than writing this series here, we can just write a simple fraction. So AN is equal to 10,000 times 1.004 to the power of n minus m outside of 1 minus 1.004 to the power of n over 1 minus 1.004. So that comes from the formula 1 minus r to the power of n over 1 minus r, where r is the common ratio. And this is n here, not n minus 1, because there are in fact n terms in this series, even though this index here is n minus 1. Now we can evaluate the denominator. So 1 minus 1.004 is negative 0.004. So AN is equal to 10,000 times 1.004 to the power of n minus m outside of 1 minus 1.004 to the power of n over negative 0.004. Now we have a negative times a negative, and we're dividing by this small decimal. So dividing by 0.004 is equivalent to multiplying by 250. So AN is equal to 10,000 times 1.004 to the power of n plus 250 times m times 1 minus 1.004 to the power of n. So expanding the brackets here, we get AN is equal to 10,000 times 1.004 to the power of n plus 250 times m minus 250 times m times 1.004 to the power of n. So we can factorize 1.004 to the power of n from this term here and this term here. So this plus 250m will appear here. And after the factorization, we get AN is equal to 10,000 minus 250m in brackets times 1.004 to the power of n plus 250 times m. Part C. Gia wants to be able to make at least 100 withdrawals. What is the largest value of m that will enable Gia to do this? We want to find a value m such that A100, which is the amount in the account after the 100th withdrawal, is $0. And if M is larger than that, then GIA cannot make 100 withdrawals. It'll be less than that. So one way we can do this is to use the expression from part B, that is 10,000 minus 250M times 1.004 to the power of 100 plus 250M is equal to 0, and we want to solve for M. So what we can do is expand this bracket here. So we have 10,000 times 1.004 to the power of 100 minus 250 times M times 1.004 to the power of 100 plus 250M is equal to 0. Now we want to make M the subject of this equation. One way we can do that is to factorize 250M or negative 250M from this term and this term. This is a constant, which eventually will end up on the other side of the equation. So we have 10,000 times 1.004 to the power of 100 minus 250M outside of 1.004 to the power of 100 minus 1 in brackets is equal to 0. So moving this term over to the other side, and when you do that, this will become a negative, but this is negative here, so we can multiply both sides by -1 at the same time. So we end up with positive 250 times M times 1.004 to the power of 100 minus 1 is equal to 10,000 times 1.004 to the power of 100. Now we can make M the subject, and we do that by dividing the right-hand side by 250 times 1.004 to the power of 100 minus 1 in brackets. So writing that out, we get M is equal to 10,000 times 1.004 to the power of 100, so that's this term here, divided by 250, divided by 1.004 to the power of 100 minus 1 in brackets. And evaluating this expression here, we get 121.527 and so on. Now it's important to note that M must be less than or equal to 121.527 and so on. So we need to round down to the nearest cent, not round up, even though it looks like rounding up is required. In other words, 121.53. If that was the case, then technically GIA cannot make at least 100 withdrawals. So rounding down to the nearest cent, GIA can withdraw a maximum of $121.52 per month. Question 26. A camera films the motion of a swing in a park. Let x of t be the horizontal distance, in meters, from the camera to the seat of the swing at t seconds. The seat is released from rest at a horizontal distance of 11.2 meters from the camera. Part A. The rate of change of x can be modelled by the equation dx dt equals negative 1.5 pi times sine of 5 pi over 4t. Find an expression for x of t. The question is asking for an expression for x of t, which represents the horizontal displacement of the swing from the camera at time t seconds. Now what's given is an expression for dx dt, which represents the velocity of the swing at time t seconds. So in order to get x of t, we need to find the antiderivative of dx dt. In other words, the integral of negative 1.5 pi times sine of 5 pi over 4 times t. So x of t is equal to the integral of negative 1.5 pi times sine of 5 pi over 4 t dt. I'm going to take out 1.5 pi outside of the integral, just to make it a little bit easier. So x of t is equal to 1.5 pi times the integral of negative sine 5 pi over 4t dt. Now the integral of negative sine is cos. And if you recall, the derivative of sine is cos, the derivative of cos is negative sine, so the antiderivative of negative sine is cos. And that's why this expression here involves cos. So x of t is equal to 1.5 pi times cos of 5 pi over 4t divided by the derivative of what's inside the brackets. So the derivative of 5 pi over 4 with respect to t, that's why we divide by 5 pi over 4. And then we add the constant of integration c, which we'll need to find later on. So simplifying all of this, and the pi here will cancel with the pi here. And we have 1.5 divided by 5 pi over 4 as well. So we get x of t is equal to 1.2 cos of 5 pi over 4 times t plus the constant of integration c. Now we know that at time t equals 0, the swing is 11.2 meters away from the camera. And we can use that fact, which is our boundary condition, to find the value of c. So x of 0 is equal to 11.2. In other words, 11.2 is equal to 1.2 times cos of 0 plus c. And cos of 0, of course, is 1. So 11.2 is equal to 1.2 plus c, hence c is equal to 10. Therefore, x of t is equal to 1.2 times cos of 5 pi over 4 times t plus 10. Part B. How many times does the swing reach the closest point to the camera during the first 10 seconds? The first thing to note is that the closest and furthest points of the swing from the camera are reached when dx dt is equal to 0. Now, dx dt represents the velocity of the swing at time t. Let's go back to the diagram. And if we can picture this swing going backwards and forwards, the velocity of this swing is 0 at the endpoints. So it's swinging, let's say, this way, slows down, comes to a halt, stops momentarily, and then swings back the other way. Comes back to this point here, which is the point that's closest to the camera. The swing will stop, in other words, its velocity is 0, and then will swing back the other way, and so on. Now, at the endpoints, the velocity is 0. At this point here, which is the center of travel, the velocity is at its maximum, assuming a forward direction, of course. The velocity will be at its minimum if it's going in the reverse direction. So if we refer to it in terms of speed, the speed of the swing is maximum at the center of travel. The speed is 0 at the endpoints. So when we talk about velocity, we need to take into account the direction of travel. So if we're just thinking about the speed of the swing, like I said before, maximum here, minimum or 0 here and here. So let's go back to our solution. So the closest and furthest points are reached when the velocity or the speed is 0. We're only interested at this point here, not this point. This is the furthest point. We want the times when the swing is at its closest point. So as the swing is going backwards and forwards, half of those times when the velocity is 0, the swing's at its furthest point. The other half of those times, the swing is at its closest point. So we need to ascertain which half are we talking about here. So if we consider sine of theta, so I'm just replacing 5 pi over 4t with theta just to make the explanation a little simpler. We want the points where sine of theta is equal to 0. That's where the velocity or the speed is 0. And that occurs when theta is equal to 0, pi, 2 pi, 3 pi, if you visualize the graph of sine theta. And in this case, theta represents 5 pi over 4 times t. So we want to find the values of t that give us a value of theta, 0, pi, 2 pi, 3 pi, and so on. So we want to solve this equation here for these values of theta. We want to solve this for t. So solving 5 pi over 4 times t is equal to 0, pi, 2 pi, 3 pi, and so on. So dividing each of these values by 5 pi over 4, we get t is equal to 0, 0.8, 1.6, 2.4 seconds, and so on. Now at t equals 0, if we go back to the diagram, at t equals 0, the swing is at its furthest point. At t equals 0.8, the swing is at the closest point, and it'll oscillate in that manner. So we got furthest point, closest point, furthest point, closest point, and so on. So following that pattern, the closest points occur at 0.8 seconds, 2.4 seconds, 4 seconds. Notice that we're adding 1.6 seconds each time to get the next time. So we got 5.6 seconds, 7.2 seconds, 8.8 seconds, and 10.4 seconds, which exceeds 10 seconds. So we're going to discount this solution here. So counting these values here, we've got 1, 2, 3, 4, 5, 6. Therefore, the closest point is reached 6 times in the first 10 seconds. Question 27. The graph of y equals f of x, where f of x equals a times the absolute value of x minus b plus c, passes through the points 3, -5, 6, 7, and 9, -5 as shown in the diagram. Part A. Find the values of a, b, and c. The graph of f of x is the graph of y equals the absolute value of x that's been translated to the right-hand side. It's been reflected in the x-axis, so it's an upside-down V, and it's also been dilated or stretched vertically. Now the question is asking for the values of a, b, and c. Now I think at this stage the easiest value to find is the value of b. Let's go back to the function definition. We have f of x is equal to a outside of x minus b in absolute values plus c. So the value of b would represent the horizontal translation. Now the x-coordinate of the vertex has moved from the origin to 6. And that's given by the x-coordinate here. Hence, b equals 6. Now referring back to the vertex, the y value is 7. In other words, f of 6 equals 7. Now we know the value of b, it's 6. Now if we substitute x equals 6 into f of x, we'll get 7. So substituting those values into the function, we can then find the value of c. So 7 is equal to a times the absolute value of 6 minus 6 plus c, and the absolute value of 6 minus 6 is 0, and 0 times a is 0, and that's why c is equal to 7. Now the last thing we need to find is the value of a. And if we choose any point other than the vertex, so either this point here or this point here, and substituting those values for x and y into the function, we can then solve it for the value of a. So f of 3 is equal to -5, and that comes from this coordinate here. So substituting x equals 3 for x and -5 for f of x, we get -5 is equal to a times 3 minus 6 in absolute values plus 7. And the absolute value of 3 minus 6 is positive 3. So -5 is equal to 3a plus 7. Subtracting 7 from both sides to make 3a the subject, we get 3a is equal to -12, hence a is equal to -4. Therefore, a is equal to -4, b is equal to 6, and c is equal to 7. Part B. The line y equals mx cuts the graph of y equals f of x in two distinct places. Find all possible values of m. To help with the explanation, I've drawn two lines passing through the origin. The line y equals m1x, which has gradient m1, and the line y equals m2x, which has gradient m2. Now the value of m must lie between m1 and m2. Notice that y equals m1x passes through the vertex of y equals f of x. I'm just going to demonstrate this with a ruler. So if I place the ruler on the origin, superimposed over the line OE, or y equals m1x, if I move the ruler clockwise, we can see that it intersects with the graph at two distinct points. So if I move it anti-clockwise past the vertex, clearly it does not intersect the graph at two distinct points. So the line y equals mx must have a gradient less than m1. Now if we consider the gradient m2, at the moment I've drawn y equals m2 parallel to EF, which means that the line y equals mx must have a gradient greater than m2. Now if I turn the ruler anti-clockwise, we can see that it intersects the graph at two distinct points. So if I move it back here and move it the other way, we can see that it would only intersect the graph at one point. So let's work out the gradient of m1. Starting at the origin and passing through point 6, 7 using rise over run, it's going to be 7 over 6. So the first point we could make is that the gradient m1 must be less than 7 over 6. Now I made the point earlier that the gradient of y equals m2x must be greater than the gradient of EF. So this is EF here, and the gradient of this line, which at the moment is parallel to EF, it must be greater than the gradient EF. And we can work that out using the gradient formula, y2 minus y1 divided by x2 minus x1. So the gradient of EF is equal to -5 minus 7 in brackets. So that's y2 minus y1 divided by 9 minus 6 in brackets. So that's x2 minus x1, rise divided by the run. And that gives us -4. Therefore, m must be greater than -4 and less than 7 over 6. Question 28. The curve y equals f of x is shown on the diagram. The equation of the tangent to the curve at point t, negative 1, 6, is y equals x plus 7. At a point R, another tangent parallel to the tangent at t is drawn. The gradient function of the curve is given by dy dx equals 3x squared minus 6x minus 8. Find the coordinates of R. Let's analyze this diagram. We have the graph of what appears to be a cubic function and two tangents drawn parallel to each other. That means they both have the same gradient. Now, the gradient of this tangent here to point T is 1. And because these two tangents are parallel to each other, the gradient of this tangent here is also 1. Now, we're given the gradient function of the curve, so it's already been differentiated for us. And it's 3x squared minus 6x minus 8. And we know that the gradient of the tangent, either tangent, is 1. So we can proceed to find the x-coordinate of point R by solving this equation here, dy dx equals 1. So 3x squared minus 6x minus 8 equals 1. So we have a quadratic equation. Let's clean that up by moving the 1 over to the other side. So we have 3x squared minus 6x minus 9 equals 0. Now it's a non-monic quadratic equation, but we can easily turn it into a monic quadratic equation by dividing all terms by 3. So we get x squared minus 2x minus 3 equals 0. And this is factorizable, easy enough. That's x minus 3 in brackets times x plus 1 in brackets equals 0. So from this expression here, we have these two solutions, x equals negative 1 or x equals 3. Now, x equals negative 1 corresponds to the x-coordinate of point T, but we want the x-coordinate of point R. So it's the second solution, 3. Hence, the x-coordinate of point R is 3. The next thing we need to find is an expression for f of x, which corresponds to the primitive of the gradient function. So f of x is equal to the integral of the gradient function, 3x squared minus 6x minus 8 dx. So integrating that expression with respect to x, we get f of x is equal to x cubed minus 3x squared minus 8x plus c. And the degree of this polynomial is a 3, which gives rise to a cubic graph. Now we have this plus c, that's the constant of integration. We need to find the value of it. Now what we do know is that the graph of y equals f of x passes through this point here, and that's given in the question, which is the coordinates of point T. So when x equals negative 1, y is equal to 6. Or put another way, f of negative 1 is equal to 6. So if we substitute negative 1 for x and 6 for f of x, we can then solve for the constant of integration c. So negative 1 in brackets cubed minus 3 times negative 1 in brackets squared minus 8 times negative 1 in brackets plus c is equal to 6. And simplifying the left-hand side, we get 4 plus c is equal to 6, hence c is equal to 2. So now we have an expression, or an equation, for the primitive function. In other words, f of x is equal to x cubed minus 3x squared minus 8x plus 2. And that is the equation of this graph here. So now that we have the x-coordinate of point R, which we found here, substituting x equals 3 into the primitive function, or into f of x, we can then find the y-coordinate that corresponds to x equals 3. So f of 3 is equal to 3 cubed minus 3 times 3 squared minus 8 times 3 plus 2, and that equals negative 22. Therefore, the coordinates of point R is 3, negative 22. Question 29. A continuous random variable x has a probability density function, f of x, given by f of x equals 12x squared times 1 minus x in brackets for x greater than or equal to 0 and less than or equal to 1, and f of x equals 0 for all other values of x. Part A. Find the mode of x. In statistics, when we're dealing with a finite number of scores, the mode is the score that occurs most often or most frequently. But we're dealing with a continuous random variable here, not a finite number of scores. And in this case, the mode of a continuous random variable is the x value that corresponds to the largest value of f of x. Using the language of calculus, that corresponds to the maximum stationary point on the graph of f of x. So the first thing we need to do is to differentiate this function with respect to x. But before I do that, I'm going to expand this expression here to make the differentiation a little easier. And in this case, I think it's a little easier than using the product rule. So expanding the brackets, we get f of x is equal to 12x squared minus 12x cubed. Differentiating f of x with respect to x, we get f dash of x is equal to 24x minus 36x squared. Next, solve f dash of x equals 0 to find the x values that correspond to the stationary points. So in other words, we're going to solve 24x minus 36x squared equals 0. Now, to make the equation a little simpler, we can divide all terms by 12. So we have 2x minus 3x squared equals 0. Factorising out x, the equation becomes x outside of 2 minus 3x in brackets equals 0. So the solution to this equation is x equals 0 or 2 over 3. Now the mode is the x value that corresponds to the larger of f of 0 or f of 2 over 3. So testing these two values of x, so these two scores, f of 0 is 0, and because it's 0, we can throw that one out and discard it. That leaves us only one left. F of 2 over 3, which equals 1 and 7 over 9. Therefore, the mode is equal to 2 over 3. Part B. Find the cumulative distribution function for the given probability density function. We find the cumulative distribution function, or capital F of x, by integrating the probability density function that was given in the question. That is, f of x equals 12x squared minus 12x cubed. What we're going to do is replace the variable x with the variable t and integrate from 0 to x. Now 0 corresponds to the minimum value of the continuous random variable, and x is a value between 0 and 1, which was originally stated in the question. So capital F of x is equal to the integral of 12t squared minus 12t cubed dt from t equals 0 to t equals x. Integrating this expression here, we get capital F of x is equal to 4t cubed minus 3t to the power of 4 from t equals 0 to t equals x. Now when t equals 0, this expression is equal to 0, and when t equals x, this expression is equal to 4x cubed minus 3x to the power of 4. Therefore, the cumulative distribution function, capital F of x, is equal to 4x cubed minus 3x to the power of 4. Part C. Without calculating the median, show that the mode is greater than the median. The median is the score that divides a probability density function in half. In this case, the integral from 0 to the median, whatever that is, of f of x is equal to 0.5. Now we don't need to calculate the median to show that the mode is greater than the median. What we do need to show is that the integral from 0 to the mode, in other words from 0 to 2 over 3 of f of x, gives us a value that's greater than 0.5. But rather than repeating the integration, we can use the cumulative distribution function from part B to make this process a little easier. So the probability that the random variable x is less than 2 over 3, in other words from 0 to 2 over 3, is given by capital F of 2 over 3. So using the cumulative distribution function from part B and substituting 2 over 3 for x here and here, we get 4 times 2 over 3 in brackets to the power of 3 minus 3 times 2 over 3 in brackets to the power of 4. So evaluating this expression here, we get 0.592 and so on, which is clearly greater than 0.5. Therefore, the mode is greater than the median. Question 30. Let f of x equal e to the power of x times sine of x. Part A. Find the coordinates of the stationary points of f of x for x greater than or equal to 0 and less than or equal to 2 pi. You do not need to check the nature of the stationary points. The first thing we need to do is to differentiate f of x with respect to x. Now f of x is equal to e to the power of negative x times sine of x. These are two functions in x being multiplied together, so the product rule will need to be applied to find f dash of x. And the product rule is f dash of x is equal to u dash v minus uv dash, where u is equal to e to the power of negative x and v is equal to sine of x. So applying the product rule, we get f dash of x is equal to negative e to the power of negative x times sine of x plus e to the power of negative x times cos of x. So that's u dash v plus u v dash. Factorising out e to the power of negative x from both of these terms, we get f dash of x is equal to e to the power of negative x outside of cos of x minus sine of x. The next step is to solve the equation f dash of x equals 0 to find the stationary points. So we want to solve e to the power of negative x outside of cos of x minus sine of x in brackets equals 0. Now either we have e to the power of negative x equaling 0 or cos of x minus sine of x equaling 0. Now note that this function here, e to the power of negative x, is positive for all real values of x. So this term here cannot equal 0. So the only other possibility we have is to check cos x minus sine x equals 0 and try to solve for x there. So solving cos x minus sine x equals 0, now there's a variety of ways we can do this. The way I've chosen is to add sine x to both sides of the equation. So we have cos x is equal to sine x. And then dividing both sides of this equation by cos x, we'll have 1 is equal to tan x or tan x is equal to 1. And x represents an angle in either quadrant 1 or quadrant 3 since the ratio is positive. And that's from all stations to central. And therefore the x coordinates of the stationary points are x equals pi over 4 and x equals 5 pi over 4. The final step is to find the function values that correspond to the x values that we just found to find the coordinates of the stationary points. So f of pi over 4 is equal to e to the power of negative pi over 4 times sine of pi over 4. And this gives us an exact ratio, which is root 2 over 2 or 1 over root 2. So f of pi over 4 is equal to root 2 over 2 times e to the power of negative pi over 4. And f of 5 pi over 4, by the same method, is equal to negative root 2 over 2 times e to the power of negative 5 pi over 4. Therefore, the coordinates of the stationary points are pi over 4, comma, root 2 over 2 times e to the power of negative pi over 4, and 5 pi over 4, comma, negative root 2 over 2 times e to the power of negative 5 pi over 4. And underneath the y values here and here, I've written an approximate decimal value, which will be useful when you look at part B. Part B. Without using any further calculus, sketch the graph of y equals f of x for x greater than or equal to 0 and less than or equal to 2 pi, showing stationary points and intercepts. From part A, we've established that the graph must pass through two particular points, which are the stationary points, located here and here. The next thing we can find are the x-intercepts. Now recall that f of x equals e to the power of negative x times sine of x. Now the x-intercepts occur when f of x is equal to 0. Now from part A, we've established that e to the power of negative x is positive for all real values of x. So e to the power of negative x cannot equal 0. However, sine of x can, and that occurs when x equals 0, x equals pi, and x equals 2 pi. And the x-intercepts are shown here on the graph. Here, here, and here. Also note that f of x approaches 0 as x approaches infinity. In other words, as the x values get larger and larger, so the further away from the origin we move to the right-hand side, f of x just gets smaller and smaller overall. And that's because e to the power of negative x approaches 0 as x approaches infinity. Think of e to the power of negative x as the coefficient of sine of x. In other words, the amplitude of sine of x gets smaller and smaller the further away we move from the origin to the right-hand side. Hence why the amplitude appears large here, so well away from the x-axis, but relatively speaking, the amplitude appears very small here. Now to fill in the gaps, or to show just a little bit more detail, I found the function values that correspond to pi over 2, 3 pi over 4, and that's this point here and here, just to get a smoother looking curve when I finally draw the curve, until we end up with the finished sketch looking like this. Question 31. 4 Year 12 students want to organise a graduation party. All 4 students have the same probability, P of F, of being available next Friday. All 4 students have the same probability, P of S, of being available next Saturday. It is given that P of F equals 3 over 10, P of S given F equals 1 over 3, and P of F given S equals 1 over 8. Kim is one of the 4 students. Part A. Is Kim's availability next Friday independent from his availability next Saturday? Justify your answer. Let's have a look at the probabilities that are given in the question. Now, the probability that Kim is available on Friday is 3 over 10. Now, if availability on Friday is independent from availability on Saturday, then the probability that Kim is available on Friday, given that he's available on Saturday, should also be 3 over 10. But it's clearly not. It's 1 over 8. In other words, this probability here tells us that availability on a Saturday affects the probability of availability on a Friday. So to answer the question, no, since the probability of Friday given Saturday is not equal to the probability of Friday. So availability on Saturday affects the probability of availability on Friday. Part B. Show that the probability that Kim is available next Saturday is 4/5. Using the conditional probability formula, the probability of Saturday given Friday is equal to the probability of Friday and Saturday divided by the probability of Friday. Now we have this probability here, which is 1/3, and we have this probability here, which is 3/10. So we can use that to find the probability of Friday and Saturday, which we'll need later on. So 1/3 is equal to the probability of Friday and Saturday divided by 3/10. Rearranging this equation to make the probability of Friday and Saturday the subject, that equals 1/3 times 3/10, which equals 1/10. Now using the same conditional probability formula, the probability of Friday given Saturday is equal to the probability of Friday and Saturday divided by the probability of Saturday. Now the question is asking for this probability here, P of S. Now from this step, we've already worked out the probability of Friday and Saturday, which is 1/10. And we're given the probability of Friday given Saturday, which is 1/8. We can then proceed to find the probability of availability on Saturday. So 1/8 is equal to 1/10 divided by P of S. Taking the reciprocal of both sides, we get 8 is equal to P of S times 10. And then making P of S the subject, we get P of S is equal to 8 divided by 10, or 4/5. Therefore, the probability of availability on Saturday is 4/5 as required. Part C. What is the probability that at least one of the 4 students is not available next Saturday? Using the law of complements, the probability that at least one out of the 4 students is not available next Saturday is equal to 1 minus the probability that all 4 students are available. Now from part B, we worked out the probability of availability next Saturday to be 4/5. So applying the law of complements in this case, 1 minus 4/5 to the power of 4 equals 369/625, or 0.5904. Therefore, the probability that at least one out of the 4 students is not available next Saturday is equal to 369/625. Question 32. The curves y equals e to the power of negative 2x and y equals e to the power of negative x minus 1/4 intersect at exactly one point as shown in the diagram. The point of intersection has coordinates ln of 2, 1/4. Do not prove this. Part A. Show that the area bounded by the two curves and the y-axis, as shaded in the diagram, is 1/4 times ln of 2 minus 1/8. The area bounded by the two curves and the y-axis, represented by the capital letter A, can be found by finding the area under the top curve with respect to x, and then subtract from that the area under the bottom curve, again with respect to x. Setting up the integral, we get the area A is equal to the integral from x equals 0 to x equals ln of 2 of e to the power of negative 2x, so that's the top curve, and then we subtract from that e to the power of negative x minus 1 over 4 in brackets, which is the bottom curve with respect to x, so that's dx. Expanding the brackets here, and this is why it's very important to show the second curve in brackets if it involves more than one term, we get a is equal to the integral from x equals 0 to x equals ln of 2 of e to the power of negative 2x minus e to the power of negative x plus 1 over 4 dx. If we don't use the brackets here, this 1 over 4 will remain a negative and we'll get an incorrect answer. So integrating this expression here with respect to x, we get a is equal to negative e to the power of negative 2x over 2 plus e to the power of negative x plus x over 4 from x equals 0 to x equals ln of 2. Applying the limits of integration, a is equal to negative 1 over 2 times e to the power of negative 2 times ln of 2 plus e to the power of negative ln of 2 plus 1 over 4 times ln of 2, so that's in brackets, minus negative 1 over 2 plus 1. Now I'm going to apply some log laws here just to make what I'm about to do a little clearer. Negative 2 times ln of 2 is identical to ln of 2 to the power of negative 2, or ln of 1 over 4. So I've shown an extra step here, just for clarity. So we get the area A is equal to negative 1 over 2 times e to the power of ln of 1 over 4. Now e and ln are inverse operations, so they'll cancel, plus e to the power of ln of 1 over 2 plus 1 over 4 times ln of 2 in brackets minus 1 over 2. Now where the e and the ln cancel, we just end up with what's inside the ln. So that equals to negative 1 over 2 times 1 over 4 plus 1 over 2, so that's from this term here, plus 1 over 4 times ln of 2 minus 1 over 2. Now this 1 over 2 and this negative 1 over 2 will cancel, and negative 1 over 2 times 1 over 4 is equal to negative 1 over 8. Therefore, the area bounded by the two curves and the y-axis is 1 over 4 times ln of 2 minus 1 over 8 as required. Part B. Find the values of k such that the curves y equals e to the power of negative 2x and y equals e to the power of negative x plus k intersect at 2 points. To find the points of intersection, we solve simultaneously the equations y equals e to the power of negative 2x and y equals e to the power of negative x plus k. And we can solve this by substitution by eliminating the y. We want to solve e to the power of negative 2x equals e to the power of negative x plus k. Moving all terms over to the left-hand side, we have e to the power of negative 2x minus e to the power of negative x minus k equals 0. Now this is an equation which is in the form of a reducible quadratic equation. And if we let u equal e to the power of negative x, we can reform this equation so it looks like a quadratic equation. So expressing this equation in terms of u, we have u squared minus u minus k equals 0. We'll call that equation number 1. Now, for 2 points of intersection, the discriminant b squared minus 4ac has to be greater than 0. So in other words, 1 plus 4k must be greater than 0. Solving this inequality for k, we get 4k is greater than negative 1. Dividing both sides of the inequality by 4, we get k is greater than negative 1 over 4. But there's something else we need to consider as well. E to the power of negative x is positive for all real values of x. So if we go back to our equation number 1, and substitute e to the power of negative x back for u, and then using the quadratic formula, we get u, or e to the power of negative x, is equal to 1 plus or minus the square root of 1 plus 4k in brackets divided by 2. Again, noting that e to the power of negative x has to be greater than 0. So we can't have any negative solutions. Which means that 1 plus 4k has to be less than 1 as well. So 1 plus 4k less than 1, we subtract 1 from both sides of the inequality, we get 4k is less than 0, which means k is less than 0. So the values of k is the intersection of these two inequalities, this one here and this one here. So k greater than negative 1 over 4 and k less than 0. Therefore, k is greater than negative 1 over 4 and less than 0.